All right, guys, today we start chapter 6. We're going to evaluate nth roots and use some rational exponents. Rational means fraction exponents. First of all, a couple of words here you need to know. If you see that means the nth root of a, also, you may see it like that. That may be even better. Nth root of a. The little number right here is called the index. The index. And the way you would read it is the nth root of a. So if you saw this right here, like that, you would say the index is 4, and you'd read it the fourth root of 5. All right, a couple new items probably for you. You can also take a square root and write it as a rational exponent or fraction exponent. Whatever your index is the bottom of your fraction. So square root of a is really a to the 1/2 power. The cube root of a is really a to the 1/3 power. The fourth root of a is a to the 1/4 power, and you could keep going forever that way. But the bottom number of your fraction, your denominator, is what your root is, or your index on your radical. Okay, find the indicated real nth root of a. So what they're giving me the nth root, they want the cube root of -260. I want to say something about this real quick. If there was an even root, I could not do it because it's wanting the real root. And even you cannot take the even root of a negative number. You can just take the odd root of a negative number. So the cube root of -216, it does have one, and it is -6, because the reason that is because -6 cubed is -216. That's why that's the answer. Second one, the fourth root of 81. And I'm trying to think what we go into 81 times itself, 4 times, and it would be 3. And again, that is the answer because if I do 3 to the 4th power, it is 81. So it's 3. Go another step here. What if you have a fraction exponent with the numerator is not 1, like m over n? In that case, the number on the bottom, your denominator is still the root, but the m is the power. So we're going to make a big deal tomorrow about the bottom is the root and the top is the power. The bottom is the root and the top is the power. You could also write it this way, the nth root of a to the m power. Now, one more case, if it's negative, you know what a negative exponent does? It flips things, so that takes it to the denominator, and it becomes the same thing, the nth root of a to the m power. The nth root of a to the m power. And of course, you could also do this. You could also put nth root of a to the m. It all depends on you. The reason I like to put the m on the outside so much instead of inside is because you're usually better off taking the root first and then the power second, because the power is going to make your number so much bigger and it makes it harder to find the root. All right, evaluate 2 of these. First one says 16 to the 3/2 power, which you know what that means. 16 to the 3/2 power really means the number on the bottom is the root, so it really means the square root of 16 cubed. So I'm going to do that part first. I'm going to do the square root first. I'm going to do the bottom number. If you want to write it out like this, you could. You could say like the square root of 16, then cube it. The square root of 16 is 4. I still have the cube. 4 cubed is 64. And that's all you got to do there. The second one has a negative, so first thing I'm going to do is I'm going to take it to the denominator, make it positive. Now what that's asking me, I have a 5 in my denominator, so it's asking me what is the 5th root of 32. So I'm really kind of doing it this way. I'm really kind of saying, okay, the 5th root of 32, I'll go ahead and do that. The 5th root of 32 is 2. And I still have to cube it. And if you cube the 2, it's 8. So I get 1/8 there for that one. One more slide. All right. They're going to have you solve some equations using these same properties. The first one says 4x to the 5th equals 128. All right. So anytime you have an equation that has an exponent, we're going to try to isolate the variable like we always do. So I'm dividing by 4 first. If I divide both sides by 4, I get x to the 5th equals 32. And because it says x to the 5th, I need to take the 5th root of each side to get rid of that radical. And over here it just cancels, get x, and the 5th root of 32 is just 2. And you can check that. You can plug it back in and check it. It would work out perfectly, I promise you. The second one has x minus 3 to the 4th power is 21. Now, there's nothing I can move over. I have a 4th power, I have a 21. So what I'm going to go ahead and do is I'm going to go ahead and take the 4th root of each side. Over on the left-hand side, the 4th root of a 4th power just cancels, so it's x minus 3. On the right-hand side, because it's an even root, I must put a plus or minus. You only do that on even roots. Odd roots, you don't need plus or minus. And so to finish up, I'm just going to move the 3 over and make it 3 plus or minus the 4th root of 21. And your book may ask you later, like to punch it in your calculator and go to the nearest hundreds place or whatever. And you can always show you how to do that tomorrow on the calculator, but it's really no big deal. You just punch in the 4th root of 21, add it to 3, and then do 3 minus the same number. So that's really it. Not too bad today. Pretty short video. Make sure you get that though. Those fraction exponents are key. They're brand new, so make sure you kind of understand what they mean. The bottom is the root. The top is the power. Bottom is the root. Top is the power. See you tomorrow.